In this lesson, we'll talk about survival data. In order to be able to model survival, we need to be able to represent the data in a form which we can process. The primary challenge is censored data, which is a particular form of missing data that we'll look at.
The missing data is common and an important issue to address while working with healthcare data. Here we'll look at when data are missing in one or more variables, the input variables, X's. We won't look at the missing outcome variable here just yet. We have a bunch of patients for some of whom the blood pressure measurements are missing. Here we use NA to show missing. Let's walk through the machine learning pipeline that we would take to then build a model, a prognostic model with this data. So the first step that we might take in our machine learning pipeline is creating a train test split. So we have a data set and we split it into a train set and a test set. And notice that both of them contain patients with missing blood pressure measurements. A standard next step at this stage is simply to exclude the records of the individuals with missing data. So we would say we won't use patient 10 data, and on the test set, we won't use patient 12's data. Now you may be familiar with this approach of dropping incomplete rows in your previous coursework or projects. But through this case study, I want to show you that there is a problem with this method and how it can lead to biased models. So at this stage, we've dropped the missing data, and now we proceed to build a classifier that tries to predict the death outcome given the age and the blood pressure. And since we have worked with random forest classifiers in a previous lesson, we will train a random forest classifier and evaluate it on the test set. So we see that the random forest classifier first gets a train accuracy of 0.87 and a test accuracy of 0.84. Now, a couple of things to notice here is that the train accuracy is pretty high and the test accuracy is relatively high too. Now, a new test data set arrives, and the thing about this test set that's important to understand is that this test set comes with no missing data. Let's assume it's been acquired with the same study design as our previous data set, but this one we have no missing data for. So now we run our random forest model on this new test set. So now our random forest model, which had achieved a high train and test accuracy, on this new test data set achieves a low accuracy of just 0.61. So what's going on?